All right. There we go. Hello, hello. Oh, got Martin saying hi already. How are you, Martin? Hope you're well today. Hope it's a good day heading into a nice weekend for you. I'm looking forward to the weekend myself, actually. Gonna get outside, do some biking. Always in the mood to go biking. All right, today. I am playing around. All good? Hope me too. Red wine has been poured. Oh, very nice. Very nice. Yeah, maybe you know what? I'm not much of a wine guy myself. I enjoy craft beer now and then. Maybe I'll have a beer with some friends tonight or something. Oh, I'm glad to hear you've got a good weekend ahead of you. Um, I want to show you this totally inconsequential thing. I'm a affiliate now, so people can subscribe and all that stuff. And I even have my own emotes. Let's see. There. They're just a work in progress, but they're my own little drawings. I'm a real Twitch person now, quote unquote, because I've got actual emotes and stuff. Just thought that was pretty cool. Enough of that though. Today I'm working on some 3D stuff. Very cool. Yeah, I actually think so too. It's fun. I wanna spend more time. The contrast and the readability of these designs doesn't work so well, really small. So I want to kind of improve those designs. But it's really fun that my own little pieces of art show up in there. I'm just proud of that. Working on some 3D stuff today. The 3D work uses my 2D SVG stuff quite thoroughly anyway, so and they end up being both useful to think about at the same time a lot of times. So I want to show you. I made this horribly, call it lazy, I guess. I made this ridiculous SDF rendering thing. And what do I mean by that? I'll actually show you, roughly speaking. If I go here, please. So A is a sign distance function in 2 dimensions, and I have this cider show function here inside the functional inside the functional representation model. Inside that namespace that I can use to show 2D SDFs as a start. So what I mean by that is if I show A, it'll render A. A is just a line. So A is actually a function that takes a point. So if I do 0, 0, it gives a distance from that point. I'm pretty sure this line I drew is 0, 0 to 1, 1. Yeah, so if I do 2, 2, sorry, I might be a little bit off base here. I forget yeah, okay, so this line 20, 20 is a point somewhere in 2D space, and this is the distance, the minimum distance that this point 2020 is away from that line. So using the fact that you can pass any 2D point into A and get a scalar distance out, you can use those distance values to set opacity of a pixel, and then just go in a grid of pixels to render out some shape. So B is a different function. It's a triangle, so I can use B and render that out as well. It'll take a while. It's, of course it doesn't look like B because I was rendering A. That's silly of me. So there we go. The blue is indicating the inside of a shape, and then the pink is like a slight radius past the edge of that shape. So I have a radius of 3 going out. So if I bump this up to 30 and let it render, you'll see that it has a fade off effect. And I want to show you, so this is quick and dirty because what I'm actually doing to make, this is a PNG image, but what I'm doing is using my SVG library to create a circle that's 1 pixel in radius. Oh, which actually, if I think about this, it should probably be like that to be more technically accurate, although it doesn't matter technically. Anyway, I'm using a circle of pixel size 1 and pretending that each circle is its own pixel. I'm really abusing the idea of this. Basically, I have circles of radius 1 in a square grid, and those circles are pixels. That's what I mean by quick and dirty. It works, but it is like needlessly complicated, right? Technically. But I made this whole function in about 5 minutes, so, you know, as functions go, that's not too bad. At least that's how I'm justifying it. Right, anyway. The reason I'm doing any of this at all, let's make that 3 again. And technically here, cool effect. Yeah, I think it's pretty neat. These, so by the way, here I have a reference thing. Inigo makes this site here. Inigo Quies, I'm not sure how to pronounce his name exactly. He is one of the creators, I believe, yeah, of the website Shader Toy. Really cool site. If you've not heard of it, you can run, you can write WebGL shaders. I think you can do both fragment and vertex shaders, and you can run it in the browser, assuming you have a good GPU. Pretty cool site. Anyway, this same person uses the technique of SDF, signed distance fields, to create all kinds of cool stuff. And these are a very helpful reference for functional representation of 2D and 3D shapes for CAD purposes. They end up being, if they're not technically the same definition, they're functionally super similar. In fact, in my understanding, they are the same. They are effectively the same thing. But anyway, you can see here, I'm going to be kind of going through bits of these suggestions here and incorporating elements of that into my 3D library so that I can have a functional representation of 3D solids built in with the other exporters I've got going on. That's the idea. Could be really useful for rapid web rendering, that kind of thing. If I can build better rendering tools, that is. In fact, while I'm thinking about this just for a second, I wonder if this will look, this is a tangent a little bit here, but I want to translate this rectangle. So it's exactly, so it's a rectangle of a pixel by a pixel, pixel wide by a pixel tall, and they're centered by default. So I'm translating it so that its corner is at 0, 0, and then I'm translating it to whatever position. I actually want to see if that, I think that'll make this a little bit brighter. I think I'm going to test that. It's technically, it doesn't matter all that much, but it was on my mind, so I'm going to do that. So yeah, it is brighter. The fall off is, you know, there's This is just, the whole reason I made this is to check that the functions I make actually represent what I'm trying to do. So C, for example, is a polyline, and I should see only a pink line. Oh, sorry, C was a rectangle, which is what you see here. And then D, I made a, this might take a little longer to render. It is I believe it was a hexagon with a little corner kind of chopped out of it. And the reason that takes longer is because I kind of implemented it in a little bit of a lazy way, but it does work, kind of. Anyway, yeah, there we go. So that, right, is a polygon. I just added, so it was a hexagon, and then I just conged another point on there just to get just to check that concave shapes work too. So one thing, I don't know if I'll do it on stream because my brain might malfunction, but if I scroll through some of these things, a lot of these shapes I don't really need for the context of CAD design, but one that's really important is an exact polygon here. And the way I've implemented Polygon at the moment, I think is rather inefficient. So if I go into here, Polygon here, what it'll do is it'll take the list of points here. Speaking of craft beer, I hear good things about Yellow Dog. Believe they're local to you. You know what? That might be the case. They ring a bell. Let me search it just for a second now that yeah, Port Moody. Yeah. So I can bike to Port Moody in 45 minutes ish. Yeah. Port Moody would be that is why it sounds familiar. I've not had, I don't think I've had it. Good reason to bike there. Yeah. Actually, Port Moody has a few breweries kind of lining certain spots of the street there. And I haven't actually had opportunity to go yet, but might want to do that. Visit some of the breweries with friends soon. Yellow Dog would be on the list. Oh, my friends are sending me jokes. There, gotta laugh at it. There we go. Yeah, Yellow Dog and Port Moody. All right, it's on the list. Thanks for the recommendation. Thank you, thank you, thank you. It's not surprising that there's a spot in Vancouver or BC that has hipster craft breweries and all that stuff. It just really seems to fit the vibe. Right, so what I was saying, if you look at this Polygon implementation, what I do is run this clip ears algorithm over the list of points to turn the point list into a list of triangles, and then I just union those triangles together to get the SDF. And it works, except that it leads to it's kind of, I'll call it sort of discontinuous, the space here. So what I mean by that is if I change this here, I can kind of illustrate what I'm showing or what I mean. So all I've done here is adjust. So there's a fall off effect. Let's make this radius just a little bigger here as well. So now I've got a fall off effect on the going outside and going inside. So instead of the inside of a shape being solid, it'll have its edge highlighted as well. And so if I now show D, the polygon shape, you'll see why I don't necessarily like the way I've implemented it, even though it does pretty much appear to work as I want it to. You can see here it's got these lines, and so you can clearly see how the shape itself is broken into the triangles here. So it clipped these ears like this, and then it triangulated everything else. So it all works, right? But if you're kind of sweeping through this and expecting a sort of continuous smooth transition, like you see here, for example, there's nice even lines and everything going in and in and in. You would not actually see that with my approach here. You would see these segmented triangles, which is not what I want for a polygon. I want, if it's possible, to get something like this, and it clearly is possible. I just have to implement in Clojure the logic of this here, and it's not too difficult, but I need to parse the syntax of this, which is WebGL shaders basically. And so the trick there is stuff like this. This is a whole list of 2D vectors. This is the point that you actually pass into the function later. So you just have to you almost have to compile what this code means in your head as you're doing it, which is possible. It's a little opaque. So I think I'm going to skip it for now because I have a placeholder Polygon function that kind of works anyway. So we'll go with that for the time being. Let's also just reduce this to 3 like that. I've also got, so the reason these are all solid instead of a fade off is because of this if statement here, and I can just cheat it by doing that, although that's silly. Let's not do that. Let's just do it this way. We'll just comment it out for now. So you can see as well, this function is not well designed yet. I'm just commenting things in and out to get different outputs, right? Which would imply that there might be, I should either expose more args, just a few up here, or have some kind of config map or something like that. But this is not the function I want to be the final one. I'm just using it as a visual testing tool. Oh, that also didn't quite do what I thought it would. I don't care enough to debug that right now, so I'll leave it be. Anyway, now, oops, I'm kind of going through this list of things and just making sure I've got a basis for a lot of this stuff. Right, so onward. Rectangle, circle. Ooh, I didn't test circle. I should test that. Okay, so let's do cider show circle 40. That worked. That worked very nicely. Let's do 200. That also worked. Pretty quick too, which is nice. I can't zoom in on this, but you can, if you look close, there's no anti-aliasing or anything like that, right? So there's all kinds of improvements to be made with rendering SDFs in like a actual nice presentable way. Circle works. Polygon temporary, like kinda, we'll call it working for the time being, which brings us to Polygon, which brings us to sphere, and now we run immediately into the issue of not having a render method for 3D SDFs. So let me think about how I want to approach that. Let's see. Well, I could. I'm gonna try the crazy. I'm gonna try this first crazy thing that popped into my head. I don't know that it's gonna work, but give it a try, right? Why not? um. This is surely a bad idea, so actually, never mind. I was gonna say I wanted to literally use the SVG library, slice, just like I'm doing an exhaustive, like I'm just iterating, or sorry, I'm just looping over every single pixel in the 2D plane for 400 pixels, x 400y, which is a lot of calculation, but it's quick enough for rough testing. My initial thought was literally do that and then also do it for 400 slices in the Z direction, but that is, I think, not a good idea. So I wonder. I wonder if there's a smart way to do it. Image Z. I've seen this library before. Do I want to do that? I mean, this surely is not a bad idea. $2019, 2 years old. I'm sure it still works just fine. Let's think of one other idea. Clojure, WebGL shaders. Let's see if there's something. CLJS WebGL, WebGL binding to Clojure script. Let's have a quick look at this, see what's up. Vertex shader source. Okay, so this does not compile. Yeah, you have to manually create your own fragment shader sources, which honestly isn't surprising. Working examples. Let's have a quick little peek here. quickly render an SDF. Okay. See, this is the kind of thing I can get to eventually. I don't think I could whip this together quickly. That's the thing. Mm-hmm. This is a little beyond the scope of what I need right now, but it is fascinating. Generating SDF textures. Bunch of cool stuff, Not what I need right now. Yeah, so what I would have to do, and maybe I can do it, make a little ray marcher that I could just use and make like small PNGs for. That might actually be good enough for what I want to do today anyway. Just make an extremely simple ray marcher. That might be okay. Yeah. Oh, I've been to this site before too. It's very useful. This ends up, so this is kind of the output I want. Oh, it's not, it's on Shader Toy as well. I see that. That's pretty cool. Yeah. Yeah. Surface normals and lighting. Yeah, I feel like this could be really quite useful, but I'll get to that another time, I think. Let's instead focus on let's see that we can get functions for all of these things anyway, right? That should be useful. Okay. So we're down, we've done all of that. Let's have a look at sphere. Let's make sure that it makes intuitive sense anyway. And you know what I can do, actually? I can slice up. I could slice a sphere and use the 2D view to at least get intuitive views of some slices. Let's go ahead and do that. That's better. That's certainly better than nothing, right? I say that's pretty good. And to do that, I basically want to, well, let's def A is the sphere of radius 20. Okay, so A will have to take, it takes a 3D point. If I give it a 2D point, it errors out, which are things I should fix, but I'll get to that later. So if I define a slice function, that could be very helpful. So what I'll do here, slice, how do I want to do it? Yeah, the frep and then the z value to slice along. So it's assuming, it's just going to assume that you'll slice, you're going to get an xy plane at z height. That's the whole thing. And all it's going to do is return a function that takes a 2D point and returns the result of vec drop last of frep of conj point with z. I think that'll work. So what's going on here? Let me just check that that works. So A is a sphere function. So if I define slice, define B as slice A at 0. Ooh, okay. I forget how vec works. Vec should take like a list of things, right? Why do I do this wrong every time? There, that works. Right, so I did something wrong here. So let's just do into, is that gonna fix it? Let's see. Oh, probably this has to be apply frep to conj blah blah blah. All right, I'm not paying enough attention here. Okay. What I want, let's do a little let here just to make things a little bit clearer. Point, right, is function of xy like this. So point is xyz like that. Then if you take, well, let's just for a second do frep of point like that. It should work. Maybe it's apply frep point, right? I can't remember. No, it should be this. This should be good. Okay, this should not error out. Okay, what am I doing wrong here? Is slice okay, A 1 2 3, yeah, A, yeah, good. Oh. This should work. Why not? Given slice at Z, I don't know what I'm missing here. Well, let's take it one little step at a time. How about that? Okay, I want it to return a function that is a point. Let's just make this function return conj point z. Okay, so this on its own should work. If I do def, oh, jeez, me being silly, I'll tell you that. Okay, so it's still causing errors here, but that's a different error now. Conj 1 2 10, yeah, that's what I was expecting. But of course B10 is nonsensical. I need that to be I still need it to be a 2D point. This should now return 10 10 0. Is 0 correct? Slice, yeah. So if let me do this now, negative 20 is where it's sliced. Now if I run B1010, it should be 10 10 negative 20. Okay, we're good there. Now all I need to do is run that point through the frep, and it should return to me the 3D point, but I want it to be 2D because I'm slicing down into 2 dimensions. So let's do def b slice a 0. Okay, so now if I do b 10 10, I do get a value, which is exactly what I'm looking for. Oh, I don't need it to, it's just a distance, so this doesn't care about anything else. So that should be good. Right, so now using the slice function, I should be able to get a rough idea of what my 3D functions actually produce. So, for example, if I do cider show slice a at 0, it's a circle, kinda. It's a little hard to see, but it is pretty cool. Let's slice a at 10. It should be a smaller circle. It's very small. Let's def a as sphere 200 instead. How about that, huh? I think that's a little better. So now let's slice a at 10. So we're getting barely any, we're actually getting barely anything showing up here. So let's just I'm not sure what I've changed. Well, let's see. Let's see what this does. That's kind of better. That's not what I expected, to be honest, but I mean, let's go with it for now. Let's change this negative r back to negative big number. So the whole inside should be colored in at least. Huh. The distances are much different. So, okay, so what if I were to do cider show a circle of 200, it'll look different, and I'm trying to think why it'll look different. I think it'll look different, I should say. It's taking a lot longer to render. Yeah, see that's what I was kind of expecting this slice of a sphere to have the same visual render as this here, because they should essentially be equivalent. Now, I think they are equivalent only in the sense of the distance being 0 at the same points. So the same surface or edge ends up being 0, so it's correct in that sense, but the distance scales differently on the slices. Does that make any sense? Kinda. Like, for this, why would that be though? Why? I think it's because I haven't adjusted the distance calculation for the actual Z position. So basically I would have to, so I'm slicing a 3D object at some position, and then I'm assuming, without actually reducing the distance, I'm assuming that that new slice is at 0, 0. So what I should actually do is not quite that. Does that make sense? I'm a little bit baffled by this, to be frank. Well, let's. No, that can't be what's happening, because here I'm slicing at 0, right? And the same, like, it's not showing up the way I expect it to. So that's not it. So let me just have a quick view of this here. So this should be a smaller circle. At the very least, that should make sense. It is. Okay, it does get smaller as you go up the radius. So if I were to do 180, it should be getting quite close to the top. So it should be closer and closer to complete. Yeah, that kind of makes sense. do that again as well, just to get things kind of looking nicer. If I do this 199, it should be super close to the top. See, that kind of makes sense. It should be almost it should be exactly a single dot. So we do get kind of the proper radius showing up there. Just trying to figure out why it renders weirdly like that. That's the thing I don't understand yet. Let's bump this radius way up and try render this out again and see what's what. Okay, I have to figure that out, why it's so much different than the 2D variants of these things. Maybe it'll come to me later. That's closer to what I want to see, but it's way off in the radius here. Let's do if I slice at something past the boundary, there is still a remnant of something to draw, and that's because the radius is quite large, right? I think that makes sense. Yeah, that kind of makes sense. Like if we were viewing this in 3D, there'd be kind of like a fading pink glow all around the sphere itself until you get, if you're at exactly the edge, you'd see a completely opaque pink render is the idea. And if you slice less, like if you're slicing vertically into the shape, the inside is colored this way with its weird limit, but ignoring that, oh yeah, if I pop this back, that should color the inside anyway. And be theoretically good enough. Oh, whatever. It's whatever, you know. It's whatever. Let's go with that like this and use that method, the slice approach anyway, to start wrapping our heads around some of these different constructs. Okay, so if I make this slice a cylinder of radius 20 and height 200, slice it at 0, I should expect to see a circle, I hope. Oh. Is that because the radius is huge? Yeah, see, that one's closer to normal. Weird. Well, whatever. I won't worry about it for now. So if I do negative 100, it should be right kind of close. If I do negative 101, it should be yeah, okay. I'm not sure where the edge of this is. Oh. Okay, so what I just discovered here is the cylinder height is actually half of the total height, and it's centered at 0, 0. So what I actually need to do is fix that. The simple solution to that is actually to go down to the cylinder here and adjust the height call, right, by just dividing it by 2 in every spot that it's used in, and that will fix that problem. That makes sense, I think. I'm just trying to think about the implication of that. That should work just fine though. Yeah, should be good. Let's, oop. H divided by 2, baby. Minus H divided by negative 2. Okay, that should hopefully work. Now, here, the cylinder is 200, and if I'm at negative 201, last time that was right at the bottom face of the cylinder, this should nil. Good. Now, if I do that at 100, and let's do 100, 0.1, so it's quite close to the face. We should see kind of either blue or bright pink. There we go, it's a real bright pink. Yeah, good. And likewise, if we go to 100, that should be close to the top as well. And if I do 101, it's getting further away. Yeah, so the opacity's dropping as you get further away. Seems pretty good to me. Da 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 da, ba da da da, da da da. Okay, so just realized I probably could like quickly generate a point cloud. Maybe. I'll worry about that later. Okay. So I've got working cylinder, sphere, cylinder, box. Let's see if box works the way I want it to. Okay, so let's define a box as 2020 so that I know the extents or the theoretical extents. So let's do box 20, oops, 20. Slice it at 100 to 1 should nil. Slice it at 0 should see, yeah, nice square. If I slice it at 10, what about 11, 20? Same problem. Okay, so all of these should actually be half, right? Is that true? Yes. Yes, it is true. Oops. Let's do length half, width half, height half is map divide number by 2, length, width, height. Oops, like that. And then here, all of these are just halves like that. And then x, y, z is the point. Perfect. Okie dokie. Now, using that, negative 20 nils and negative 10.1 should be a bright pink. Yep, and it's a smaller thing. It should be, that should be about 20 pixels. I think that makes sense. Yeah. Yeah. Same on the top, yeah. If I make this 10, it should be blue. Yes. Perfect. Things are coming along decently. Wouldn't you say? Ooh, excuse me. Boy, oh boy. Boy, oh boy. Okay. Sphere, box, cylinder, polyhedron. Skip for a moment. Wait, why is this down here? That's not correct. Let's do that. Box, revolve, extrude, yeah. Yeah, I think that makes sense. Let's see. Let's see about extrusion now. Yeah, I think that makes sense. So extrusion takes a function, takes an frep function that's two-dimensional, creates a 3D functional representation. So D is some initial distance to a 2D thing. So you have to drop the last point because it's just it's assumed to be extruding along Z, which is similar behavior to OpenSCAD. Might be good to have some extrude along or extrude with a vector that you could point to the direction, but I won't worry about that right now because I might just implement that as transform the shape so it's normal points along Z, extrude it along Z, and then transform it back so that it's normal points along the direction that the user specified. That would work. But I'll worry about that another time. We just get good to get some of the basics in here, right? Well, let's see if this works. Okay, so let's do here, if I slice, not a box, but well, let's slice at 0. Let's slice the extrusion of a, let's extrude at a height of 100, and we'll extrude a rectangle that's 30 by 50. Hey, it worked. Cool. Now, let's extrude that at 101. No, 100.1. We should see, if it's right at the edge, we should see bright pink. Okay, so extrude behaves differently than a default cylinder in that, oops. Actually, let me, before I say that for sure, let's see if this height doubles out back there. Yeah, okay, so this is wrong. Do I want extrude to I don't know what default behavior I want it to have. Do I want it to extrude a thing and then center it on the height? I think that kind of makes sense because that is how, let's say, cylinders and boxes behave by default. It kind of centers it in all 3 dimensions, not just X and Y. But a 2D sketch doesn't do that. Hard to say. I'm going to go with not centering. How about that? Let's do... Yeah, so what I mean is this 0, if I do a slice of an extruded shape at 0, I should see a solid blue slice, but right now I don't because I'm in the middle of the extrusion. I want it to be half that height and translated so that its center is at half the height as well. So I have to modify this function, which is not too big a deal, honestly. Should be okay. Let's try to decipher what I've done here. Okay, so the frep is 2D. So we drop the Z value and then we'll get the 2D equivalent distance to the thing as if it were right away on its plane. So that's some distance in X and Y. And then W is some vector containing D, the distance value. This ends up being a scalar, last of point is z. So you take the absolute value of z, and then you do your height value minus z. So you get, why did I do this way? This is a little weird. This is weird. So I don't need first of w like this. Let's just make this like that, and then I can just do max, not of w, but max between d and w, and then here max between d and 0, and then max between w and 0 here. So that's something, and then you just do the distance between those, right? Plus the minimum between 0 and the maximum of those. So if I want to, so first of all, divide h by 2 to get the right total height. And then if I want this to work out, I actually need, so the minimum of all that, and I need to modify the whole distance by wait a minute, let's check that this makes sense first. So it should be solid. Maybe my modifications didn't work. It's very possible. Extrude 100, slice 100. Oops. So this should be solid blue, right? Because it's at the top. Ooh, nil. That's the wrong number. 50. This. Yeah, okay. So that, and then negative 50. Okay, so we have the correct height now, but we're still centered at the origin. Not a bad thing per se, but not exactly what we want. So let me think about that. How do I change it? Think about it in a minute. I'm gonna go to the washroom and I'll be right back. Yeah, so it's not quite as simple as adding half the height, is it? I mean, I'll check. I don't think that makes sense, but let's give it a shot. Add into the total distance. H divided by 2 is going to be wrong. But let's see what shows up anyway. Okay, so we nil out at minus 50. So let's see what it looks like at 0 exactly. If it's blue, yeah, it's still nilling out, right? Which is not correct. And at 50, it should be... Oh, well, I'm adding... if I go above 50, does it suddenly start showing up? Did I shift it by the wrong... It's way off now, so let's add h divided by negative 2. Still won't fix the problem. It's still incorrect. Oh, interesting. It's a different shape entirely. That's pretty cool. Yeah, and that makes sense, right? Because I'm at like the height, or pardon me, the distance. It's a distance in 3D space, right? So if you're adding or subtracting bits of the distance, it'll affect the whole 3D shape. What I need to do is modify the math more directly. And it has to happen. Well, it can happen right here. If I take the point that I give it and modify, if I add to the z value, actually I don't even need to do it here, right? Point is point. Here, if I take last of point and add, I was just gonna say, if I do the last of the point plus some value, right? I was gonna add, oops, did I add one too many? Yeah. If I add half the height to the z value, but then I'm immediately subtracting it, so that makes it pointless. Oh, I have to do oh no, it's not necessarily pointless. Let's see if I'm even thinking about this right. Well, 55 is out of the range. That's good. 50 should be right at that edge, so solid blue. Nil. Yeah. Where's 0 at? Okay, 0's right now. Why was 50 not correct? Let's do 49. Ooh. Sorry, that's... Extrude this 100. Slice 0. Okay, that's looking good. Let's slice at 100. Should be, it's nil. I'm closer, but still not thinking about this correctly. Am I modifying this correctly? Let's check that. Extrude 3050. The height is 100. Oh, it's inverted. So if I do negative 100, is that exactly capped? Okay, so we're correct. We're exactly wrong, which means we can very soon be exactly right. Right, so to do that, all I have to do is flip this. Has to be let's see if that's gonna be right. Yes, okay. So let's do the check here. 100.1 should be bright pink, which is like right on that top surface. Yeah, looking good. Now the negative of this should nil. Ooh, it's not. Yes, it is. Okay. So let's do negative 0.1. So it's right, it should be bright pink right at the bottom. Good. Okay, so we fixed that. Let's sanity check this with a more let's just do a slice at 25. It should just be a rectangle basically. If we now extrude polygon with utils/regular polygon points, radius 40, and edges, let's do 8 for fun. Okay, got to give that maybe a minute to do its calculations here, but it should give us an octagon with a bunch of blue lines through the middle, I think. Yep. All right, that's promising. Okay, so for sake of moving on, I'm gonna call the extrusion working. And now Revolve, the weirder, maybe weirder one to kind of try out, but let's give it a shot. Let's see what we've got going on here. F and R. What did I do with this one? Let Q be distance between first point and last point. So X and Z, because the point that's going to be passed in here is a 3D point. Minus the radius no idea. I don't remember, basically. Let's see. I think I might have based this off of a 3D Revolve thing here. Let's see. Torus exact, infinite cylinder, cones, planes, triangular prism, capsule. Rhombus, triangle, quad. Ooh, this is gonna be useful actually. I could that's probably gonna be very helpful, but I'll get to that later. Alterations, elongation. right, where was I? I think I've got about 45 minutes of brain juice left for the day, to be honest. But we'll see what we can do. Okay, so I can't remember exactly how I did this. It's not this, it's here we go. Okay, this is the area where, yeah, okay, so I clearly used this as well as the basis for my implementations, and I'm okay with that. Here, revolution, 3D point, the thing here, and O. I don't remember what O is at the moment. Let's see. Oh, I wonder if O, no, it's a float value. So it can't be, I was going to say maybe it's the origin point, but it's a single float, so it can't be a point. Q. Oh, right, and then you run, so Q becomes a point. Oh, geez. All right, let's just see what happens when I do this. Let's show a slice. Instead of extruding it, we'll revolve it. 1. Oh, we should slice at 0 as well. So we get the... Maybe we should do it with a circle or a rectangle, a thing that we know will calculate a little faster. I think this will... Whoa, that's super weird. I love it. Yeah, so I think it's working. But I have to probably translate to make it work the way I do want. Okay. Okay, so I think the revolve is working, but because the shape is the 2D shape is already centered at 0, 0, it's just revolving around itself, and so you get this kind of weird sort of thing. I want to change, first of all, let's slice it through 0. Let's change this to 5 maybe, and the revolve, we'll change that number to 0 and see what happens, because I just can't intuit right now what float 0 here actually means. This is cool but weird. This is exactly where a proper 3D ray march would be helpful, and I think it's probably an important thing to do next or very soon. To confirm, let's I can make a quick change to the polygon itself here by doing utils slash v plus actually map utils v plus the point 50 0. So we're shifting the whole thing over in the x direction, and then I just need to map that over the points. Did something wrong there. That's okay. Let's pick this apart just a bit. Let's make this revolve. Sorry, let's do this. Oh, I mapped on the wrong spot here. That's why. This has to be here. Map that function over this utility. Does that fix it? There we go. That was confusing. Well, if this is working the way I think it is, yes. So this is confirming what I thought. So what's happened here is, so I've drawn a polygon. I've moved it away from this, from the origin. So it's 50, the center of this pentagon is 50 points away from the 0 position. Then I did a revolve, and the revolve operation will revolve about, it looks like the y-axis. No, sorry, it's actually revolving about the x-axis. Is it? If it were revolving the shape about z, then this wouldn't look quite like that. Let me stop talking about it and just manipulate where I slice. Let's slice it at 10. We should kind of see this. Yeah, it looks like it's revolving about y, actually. So if I do 30, if I go up through this enough, it should, like, these should kind of join up into a single shape, because if it's like revolving like a donut, I'm slicing closer and closer to its top. That looks pretty cool, actually. I like that. Yeah, that's pretty neat. If the radius of this polygon is 40 here, and I've moved it 50. 70 should be right at the top of this thing. It should basically be kind of a thin line. I think that's correct. Does that make sense? It's close to right. I did move it over 50. If you revolve a thing that's 57, yeah, it should. I thought that would be different than it is. well, no big deal. Just keep poking around at it. When I finally make a proper 3D renderer for this, things will be really nice and clear. But in a pinch, this is working okay. It's kind of fun to try and think about it too, which is neat. Yeah, so let's do 90. So it's not nil. Wait a minute. Why would that be that way? I don't know, but if I change this to 6, this should change not from just a little dot to a line, I think, a vertical line. Oh, actually, no, that shouldn't matter at all, because the way I've implemented the regular polygon points, it'll always be at the extent of the radius of the polygon. It will always be a single line like that. So it will, no matter the number, I mean, unless if I go with a really high number, you might start to see a bit of a spread there, but technically it'll always be a singular point that is at the extent. I never make the polygon radius to the middle of an edge. I make it to a node, to a corner. So it'll always be a corner that shows up at the revolve. Is that making any sense? Might not make sense. But it's okay. Here we are at the limits of usability of the SDF viewer that I made. This is impractically slow. If you get things into like a GPU pipeline of some kind, you can make this stuff go a lot faster. Obviously that'll be important because this is taking a long time. I also realize I want to check. I wonder if O is I'm gonna assume that this will still work at some point. I'm gonna leave it be for now. I wonder, change of metric. These are fun. These are where things get really cool. Because you get nice blends and stuff like that. I think that's so neat. Symmetry. Excuse me. All right, so oh, that's cool. We're getting beyond. I'm surprised this is not done yet. Oh, there it is. Yeah, so not exactly helpful. Let me bring this thing back down to 6. Let's slice through 0. Let's make this 90. I'm not sure that the O value, I just don't know what it does. That's the problem. I wonder if there's a shader toy example that I could just modify it and see what changes. Let's try find that. Oh, okay, I think I know what that value does. I think it displaces, I think it sets the radius about which the shape will evolve or revolve. So yeah, so if I get rid of this part here, oh geez. Okay. I want to change that function signature if that's what it, if I'm correct about that, I want it to be different. Oh, I messed this up. Okay, so let's slice a revolve of a polygon of utils slash regular polygon points. The radius of it is 40 is good. It's a 6-sided thing. That's good. So we'll revolve the polygon, and I want to revolve it 50. Oh, if I do 40, then slice it at 0. Oh. Yeah, like that. These, I should get a shape that looks like this, but these 2 points should be exactly coincident. If that's true, that is good. Yes, okay, now I understand what that's all about. So I actually can do this differently. So what, I don't want the R there. I want just trying to think about the right way, excuse me, to handle this. See, the thing about the revolve function in OpenSCAD, which I'm using as sort of a CAD utility reference program, lets you specify partial revolution. So if you give it a shape to revolve and an angle that's less than 360, you'll get a partial revolution. So I actually don't want R because I can handle positioning of the shape independently. I need to do a few things to get the orientation of this thing to work the way that OpenSCAD does, or I just change the convention for what I want it to be in my program. It doesn't have to be the same as OpenSCAD, it just has to be similar. So what I'm going to do here is actually get rid of R. So Q is just the distance without an R difference. It's super easy. I think that should actually be fine, right? Q is this thing as is. So now if I do that, this should, ooh, this value here, no, this value here. This should work. And we should see a kind of, it should basically be a hex shape, but since it's revolving over itself, it might look, it might have weirder lines in the middle. Yeah, but it is still a hexagon because it's not moved away from the origin at all. So for example, if I do, one second. If I were to revolve this polygon, but I want to do that map situation I had going on before, map utils / v plus 40 0. This map, I want to uh-oh. Map. There we go. Oh, come on. I messed it up again. I've done that a few times. Let's boosh. Come on. There we go. Right, so this should look like the previous one where two of the points are coincident because I'm handling the movement, like I'm just translating the shape before I put it through the revolve. But now if I were to do this, if I don't move it on X, I only move it along Y, it's rotating about Y, I think, so it won't look, it'll look, I think it should look basically like this, just technically it's not a 0 0, it's at 0 40. Yeah, so is there a way that I could make it rotate about Z? That's kind of what I actually want to happen. And I do believe there's a way. So the distance here, it's first point and let's try second. See what happens. Very cool, very weird. In the case of revolving something around Z, this, trying to build an intuition in my brain about what I would expect to see. This is super weird looking. I love it. Right. So I think I should probably go ahead and make a little OpenSCAD equivalent here so that I'm not flying totally blind, you know? To do that, I can do this here. Def C as threading, model slash polygon, utils slash regular polygon points, 46. Yeah, so that, oof, it's a little annoying. Right, then we model translate that 040, nope, sorry, 40, 0, 0. Then model revolve 360. Cider show C. See if that works. Hopefully it does. Yeah, okay. So this and that are the same. Is that true? It's not really. Man, I'm confused. I love it. Right, so if I so this is a Z slice here, right? So we're seeing the same shape. It's oriented differently though. That's the thing that's happening here. I would have to turn it 90 degrees on X to orient it the same way as this. I think that's what's happening. So excuse me. Actually just had a super ridiculous idea that might be fun to try. It won't compute fast, but it will be ridiculous, and I like that sometimes. I can't do this actually in production, I don't think, because it'll have a circular dependency, but if I do forge.compile.scad, is that gonna work? Okay. So show 3D takes some frep and does this whole business, let's basically start by copying this. Let render be filter sum for x, y, and z. We'll do that. Risky, I know, but that's okay. Right. Let's do point is x, y, z. A no, this has to be forge model sphere 1 model translate. I don't need it to translate actually, except I need this one, model translate to the point. But I should actually do, well, okay, let's, this is gonna go horribly wrong. But let's see what happens. How about that, huh? Let's get rid of this style business. We don't need it. The reason this is going to go wrong is because it's going to take a really long time to calculate for all these points, right? Like it just is a lot to handle. So not great, really not great. But let's try it anyway because it's fun. And here we just do SCAD cider show the render, right? That works. Yeah, it should work. Well, let's see. Let's do show 3D of a sphere. I don't expect this to actually work. I expect me to have forgotten something. But let's see what happens. That's always fun. So this is kind of like the brute force approach to voxels. Whoa, it looks really cool. It's definitely not not great, right? But it is very cool. I love it, kind of. Well, okay, so let's do this now with was D an extrusion or was it a 2D shape? I don't remember. So this is basically I'm using spheres to represent point positions, so it's kind of like it's a point cloud representation of a thing. There are better ways to do it, for sure, but it's better than nothing as a start. But you can see where these things might start to go wrong, right? It takes a long time to calculate. Even when I have a bounded volume that's only 200, it's only 400 by 400 by 400. It's a lot of space to have to calculate stuff through, right? So the brute force approach is not the best. Who knew? I think everybody knew. It is fun though. I should make it export a SCAD file, open that in SCAD, and be able to 3D rotate it instead of just wait for it to make a PNG and then quit. I think I might have to quit soon because I'm getting a little bit bored waiting around for this and realizing it's not going to make the best stream. So probably time to call it soon. It's pretty early, but it is a Friday, so give myself some of that time, But I do want to see how this actually works before. Is it even calculating? It might not be. Let's try. Let's do show 3D of a unique thing. Let's try extrude first. Let's do extrude a circle of radius 30 to a height of 100. Should still take a minute, but it should complete computation at some point. I should probably decrease this total range thing here. What I could do as well is decrease the steps in any one dimension, so I can get a visual of, like, get a higher resolution in X and Y, and then just have fewer steps along Z to still get the idea. That would probably work. So I do that by saying, okay, it's the same range here, but the step size is 5 instead. And even this would help. Let's sanity check. Is this working? This should render something out. Maybe I'm just getting impatient. It is possible that things aren't working the way I expect. Okay, there we go. It's working. Working. So this should look way weirder, but still kind of work. Step size is way off, but so using that reduced thing, let's see, this should actually render something. It might not be helpful in terms of useful visuals, but it's a start. Whoa, cool. Okay, so it's a much higher density. It's just the sphere is not, I wonder if I implemented the sphere incorrectly. That's something to look into. This is cool. This is working. It doesn't, I mean, it's not beautiful, but it is really neat. Right, so let's revolve a circle now. And we'll do revolve this way, where let's actually revolve. Let me do this. Please, there we go. Let's define A to be a set of points. No, we'll make it a whole polygon. So it's a polygon that contains map utils/v plus. This point, we'll move it 50, 0. Over utils/regular polygon points. Let's make it a 6-sided thing. Let's do 36 like this. Okay, so A is a function. It's a 2D thing. So now let's go show 3D. Revolve A. So it should be a donut-like thing if and when it computes a render. This is so inefficient. It's gonna be fun to make it better. That much is true. I am going to, once this thing renders and I have a quick peek at what it actually looks like, I'm gonna get going after that. So any time now. It will obviously take a bit to render the whole thing because I'm sure there's a lot of, well, it's doing a ton of checking, right? That's one of the problems with this. It creates a massive list of points, right? So it's going to be 200 times 200 times 25-ish, right? Which is 1 million points that it's checking, and I didn't do any async stuff. It's purely working on a sequence. It's checking 1 point at a time, calculating it's running that point through the distance function, which is gonna probably have, or that it's running each point through the frep, and it's using distance calculations which have square roots in them. So you're doing a million things. You're calculating distances that are going to be small but use square root calculations. You're not filtering it out in any way. You're doing the calculation and then you're filtering based on the calculation's result. So you got a bunch of slow stuff happening. That it's just not an efficient approach. There's better ways to do rendering of SDFs. And as you can see, like, you can make shader toy stuff work way faster. So yeah, this, by the way, looks like I could actually modify some of this stuff here. Let's see. I don't need to do that. Point is, please work here. There we go. This is calculating live, and it's running at 60 FPS. While this is not doing a live calculation, and it hasn't finished yet, right? Like, it's so clear what the better method is. And these SDFs end up being rendered via so main image here, Anti-Aliasing. This is something I have to look into again, but I'm pretty sure this basically just implements a ray march or a sphere marching ray. I don't remember what it's called, but it uses spheres and rays for each pixel to get the value of the color of the pixel based on the SDFs that are in the main image function. Does that make sense? Kinda. It's only ever doing whoa, there, interesting. That is not what I expected to see. Well, okay. I think I just made a bad assumption about how I could modify the revolve here. I'm pretty sure what I'll end up doing to get it oriented the way I want is just revolve it around Y like it is, and then do an implicit rotate around X so that it has the equivalent appearance of moving around Z, just like it does in OpenSCAD. I think that makes sense. But I'm going to get going. This is computing. I'll be working on this as I go, but I'm not really doing much stream-wise, so I'll be back next week. I hope everyone has a great weekend. If you're watching this at some other point, please consider subscribing to all my stuff. The YouTube channel, for example. Leave comments. Follow the Twitch stream. Whatever you can to help out would be really cool. But that's all. And I'll be back next week. Bye-bye.